This is the next lecture in the series of solution to the network theorems. And first, what we saw about in the lecture one, we saw about the active elements and we saw about the passive elements. Then we saw about the different components like the inductor, capacitance, etc. Then we saw the KCL and we saw the KVL and we saw the Kirchhoff's voltage and current law. Then we saw the series and the parallel circuits for the solution of the equation, was for simplifying the circuits. Then we applied or we learned about the mesh analysis or loop analysis, and then I talked about the last lecture was about the node analysis. So it's possible to solve this same circuit by using both loop analysis, or you can apply both nodal analysis also on this circuit. Also, it's possible to solve the circuit using KVL and KCL also. You can try that also. So again, all these methods are possible, but again, we are taking a simple example, but in exams it could come specifically to solve a kind of a problem using a KVL, or to solve a problem using KCL, etc., and or using the loop method, node method, or you can even to apply the Thevenin's method or superposition theorem, etc. So while you are solving this circuit using superposition theorem, so what superposition theorem says is that when there are more than one active elements in the circuit, so it is possible to find the current or the voltage at a specific node. Like in this case, we are going to consider the current I2. We are going to find the current I2 in this circuit. So it's possible to find the current through any of the passive elements, or the voltage at any of the nodes, etc., in the circuit if it is asked, by considering each of the sources. Like there are two sources here which you can call as active elements, so considering only one active element at a time. So in case of current source, which is a active element, what we will do is that we will open circuit it when we are not considering that. And when there is a voltage source, so if we are considering this independently and we are solving it first, and we will find I2, and then we will consider this only and we will short circuit this at that time. And while we are considering the voltage, we will open circuit the current, and we will independently by only considering this voltage source in the circuit we will find I2, and only considering this current source we will find I2. And so the equations the circuit will become simplified, as this part will be omitted, and this part will be short circuited again during the second case. So the solution to the circuit can become simpler. So that's one of the reasons why you might want to apply the superposition theorem to any of the circuit. And again, the current which you will find like I2 by considering the first active element, and I2 by finding the second passive element. So this will be the two currents which you will be finding, and we will see as we solve them. So again, the current I2 will be the summation of both these. So again, considering the case where we have not considering this source, so we have open circuited this, and so this part of the circuit will go away. And by considering this the I2, that is a current we are intending to find, we find the equivalent resistance as 20 ohm, because both these are in series. So I2 can be found out by V by R, so it will become as 1 ampere. So again, you go to this circuit, and what you find is that now we have done away with this voltage source, so we have short circuited this. So now this is 10 ohm, now this is 10 ohm, and this is 2 ampere as it is now. So we have brought this into this scenario, and now this is 10 ohm here. So again, both these are in parallel, so we'll have to do the parallel equation to solve that, and we'll find it as 10 ohm, and again this is 10 ohm. But this circuit is very simplified, and we find that since there is only one source and is a current, so I2 is 2 ampere itself. So the total current is 3 ampere, and that's how we have found out I2. And again, if it is also asked to find out uh, I1 in the circuit, then you can apply the KCL at this node, and then I1 is equal to I2 plus I3, and you know I2 now, and you know also know I3, so I1 is equal to 1 ampere. So this is one just simple example which I formulated myself to help you to find out what superposition theorem was all about. So in superposition theorem will be mostly applied to circuits which have more than one active element, and we can find out the current in any of the passive elements or the voltage at any of the nodes by considering only one active element at a time, and open circuiting the current in this current source in the case, and short circuiting the voltage source, and solving the circuit independently for each of the cases. And that's all. If you like this video, please do subscribe to my channel. Also, I will be teaching more about the electrical stuff in this channel. So coming to the next video will be about the Thevenin's and the Norton's law. So these are one of the most important theorems about in network analysis, and are usually used for solving large networks like a large power system networks, etc. Can be simplified using the Thevenin's and the Norton's theorems. Uh, that's all. If you like this video, do subscribe.